Hi folks, pumped to be joined by the local engineering team responsible for protocol and cloud experiences, and two of those like to shop at the same store as well, as you can see on their shirt. Hey, they're going to show all the latest new enhancements and demos as well about these cool experiences coming from the cloud. So let's get started. Hi folks, I'm pumped to welcome you on another episode of Windows in the Cloud. This time around, our streaming experiences of Windows 365 and Azure Virtual Desktop as well. So as always, please make sure to subscribe on our Windows IT Pro YouTube channel by the link below. And with that, let's introduce our guests. So, hi Jordan, how are you doing?
I'm doing great, Christian. How about you?
I'm great as well, and great to have you on this show for the first time, I believe. So, can you share the audience a little bit, like what your role is on the team here?
For sure. My name is Jordan Marchese. I'm a principal product manager on the AVD and Windows 365 team. My primary area of focus is around redirections. So how we make anything from peripherals to device state signals from a client endpoint device, how we make those show up in the remote session and make that experience feel as local as possible.
Yeah, it's great to have you, and the history of you and Windows as well. I think it's just a sweet spot to have you on the team here. Hey, Rinku, welcome back. You have been on the show before on Teams and other experiences like redirections as part of Microsoft Teams. So for the folks that didn't watch that episode, can you share who you are and what you do as part of this team?
Yeah, hi, I'm Rinku. I'm a senior product manager for Azure Virtual Desktop and Windows 365. My main primary focus is in connection reliability space. I'm very glad to be part of this series and give more information on the investments that we are doing in the connection reliability, as you've seen.
Yeah, great to have you back, Rinku. And last, definitely not least, the least here, Angelo. Great to have you for the first time on this episode as well. Can you introduce yourself?
Yeah, thanks, Christian. Super stoked to be here. My name is Angelo Gaka-Siosin. Everyone calls me Ang. I'm a senior product manager here on the Windows 365 and AVD teams. My areas of focus are the graphics pipeline as well as connection times. Super excited to be here and talk about some of the more recent features that we have.
Yeah, really excited about all these demos that you all prepared, and the content as well as end-user experiences. Streaming is really what makes our service shine to the end user. So really curious, what you all have been preparing for the audience here. So before we jump into that, Jordan, can you share some more about the history of the protocol and how it evolved to the leading protocol in terms of performance right now out there in the market?
For sure, Christian, would love to talk about that. So RDP as a protocol has been around for nearly 30 years now, and it started back in the 90s when we had server and we needed to connect, one computer to another. And over time, this virtualization has changed. We've gone from, server-based into now with multi-session VDI, and then one of our first big jumps that really happened was when we launched on Azure, when we started our IaaS solution. And this was the first time we really took a Windows to Windows PC connection and moved it from Windows to the cloud. And as I mentioned, the backbone of this has always been RDP as a protocol, but as we've continued to make forward progress in the cloud space, moving into Azure Virtual Desktop and now Windows 365, RDP is still there behind the scenes, but as we move to the cloud, we have to continue to evolve because we are now dealing with a new myriad of issues that we didn't have before, whether that's connection to Azure, to now more client endpoints that we've never supported before, and even brand new, cloud unique scenarios that do not have a local analog paradigm.
Yeah, I think you bring up a great point here. RDP backend server was getting updates every new server release, and now in the cloud it's ongoing, constantly being updated, right?
Correct. Yeah. And Microsoft has had the history of, yeah, we used to ship RDP with Windows updates, server updates, etc. And so we've taken that as a backbone and and now we've moved to a state where it's not just Windows to Windows. As we've mentioned, we now have these cloud offerings where we roll these out through our stacks that run in AVD and Windows 365, so we can rev changes to the protocol faster than we could via Windows releases itself.
Yeah, I love that. And is that one of the reasons why we don't call it like RDP anymore and like local right now?
Yeah, I mean, we're in this unique journey now of what do we call it, because it is this collection of services. RDP is the backbone. We have a bunch of microservices, partnerships with teams and others to create these like local experiences. And so really what our team focuses on is that bridge from protocol to experience. What we call it and how we scope it is something we're still honestly trying to figure out. And this is, I would say a ever evolving problem in the new cloud world that we're in.
Yeah, this is great. And I know that Angelo, you own some of these experiences parts that Jordan just explained. So to bridge kind of back to you, like, what are we doing there in that area? What are the improvements that spread across these layers that Jordan just explained?
Yeah, connection time is a really great example of one of our like local areas of focus that's impacted by what we're doing at every layer that we kind of just talked about. Establishing a connection to a user's remote machine, it's something that requires really careful orchestration of a process that touches every layer that we just mentioned, right? And that's something that we're continually focused on improving. Where in this connection process can we focus to shorten the time it takes for a user to establish a connection from their client endpoint to their host machine? When we think about this whole idea of being a like local experience, like the idea of connecting to a machine that is yours, but in the cloud through a local client machine and making that whole experience as if you are just working on that machine locally, the entry point to that whole experience is connection time. So that's one place where we're really focused on trying to see how much we can shorten that connection time. So the process of connecting a user to their cloud PC can approach what it takes to log into your local machine. Some improvements that we made over the last year to that end are optimizations to the way that auth tokens are created or acquired. We've also done an introduction of an enhanced authentication protocol. In that process, we've implemented RDP file caching so that the RDP file is already there when you're establishing your connection. And then we've also changed the number of calls that Windows 365 needs to make to Microsoft Graph. Reducing the number of calls means less time, means a faster connection. So those are just examples of some of the improvements that we've made in about the last year or so. Our approach has really been to continuously make small improvements to the connection time as we identify those opportunities. And those improvements can be small, and we'll introduce them as we make them. One thing that I'd really want to show here is a demo that I think kind of captures how much of these improvements can be made or have impacted the connection time experience in the last year. What we're showing right here is a demo of two connection processes side by side. So both of these scenarios are connecting to the same cloud PC from similar environments. So that's things like network connectivity, distance to the data center, things like that. The only difference between the left side and the right side is that these were recorded about 1 year apart. So all these improvements that I've been talking about, they were made between the time the left side recording was taken and the right side. You can see like the collective impact of all of these improvements for this particular user with their environment is an improvement from just under 23 seconds to connect to just under 7 seconds, all things the same.
Yeah, that's so cool. And that was so fast, like compared to any traditional virtualization solutions I have been experiencing in the past myself. This is really game changing. And I also know that this is not where we stop, right? Like, I think we want to get to the speed of light. Is that correct?
Well, what I can tell you is that these improvements are certainly not where we plan to stop with regards to improving the connection experience. Like I said, if we think about like local and we think about connecting to a cloud PC and making that like local, well, the local analog to that experience is logging into your computer. So if you've already got a computer that you're waking up from sleep or unlocking, you type your password, you hit enter, that's fast. And we want to try to get our cloud experience as close to that as possible. And that's what we're going to continue to do with this approach, where we find opportunities in this connection process, introduce them, and make the experience faster and more like local for our users.
So question for you. We just released our first Cloud PC device, Windows 365 Link. Would this experience also work on that device the same?
Yeah, absolutely. Like the idea here is that, independent of that new experience on the Windows Link devices, we offer the Windows app and connections to our Windows 365 experience on a variety of platforms. And the improvements that we're looking at, when I talk about touching every layer of the service, we want those improvements to be things that can accrue to as many of our experiences as possible. So to answer your question directly, yes, these experiences these features that we're introducing to improve connection time, you'll see those across all the experiences that we offer, including Windows Link devices.
Well, thanks. This is great, but this is not where you stop today. You have one more demo for us as well, so we'll come back to you in just a bit. Rinku, we do some awesome stuff on like improving the reconnecting, disconnecting experience. Like, can you share more there? What we did there?
Yeah. So, Christian, we have invested into a feature called RDP Multipath, which significantly reduces the number of disconnects and improves getting connected quickly. In line with what Angelo was doing. We want fast reconnection in case every disconnection happens. What this particular feature does, first of all, I just want to say that to get this particular feature, there is no network configuration that anybody has to do either at the user side or at the VM side or by the admins. This feature just seamlessly integrates with their current setup. Second most, how does this feature work? Is basically we continuously evaluate multiple paths connecting the user to their cloud PCs, and we dynamically and simultaneously switch at runtime between the different paths. When we try to create these paths, we try to see that they don't have a single point of failure. So in case if one of the paths gets disconnected or interrupted due to any glitches, then only that path is impacted. The other two paths are still operational. So you behind the scenes, in less than a second, we switch to the backup paths so that the user is not impacted by the whole thing that we're doing behind the scenes for the user. So I have a demo which I'm just going to share where it's a side-by-side demo where with current RDP implementation where we do not have this particular feature enabled, where I'm manually simulating a disconnect. What do we experience like? When it gets disconnected, what user sees is that you get a blank screen and then you get auto reconnected, and this whole thing happens in a period of a minute. Now I'm going to show the demo where multipath is enabled, and I'm going to simulate the same interruption that I did in the previous demo. If you see that the user is not impacted by that, we switched it from one network interface card, the connection that was going through Ethernet 4 to Ethernet 5 behind the scenes, and the user even doesn't come to know. So to conclude, this particular feature is aiming for higher MTTF. What it means is the user is able to be productive and continuously work during their work time without getting disconnected and reduce the number of disconnects. Yeah, that's it. Do you have any questions here, Christian?
Yeah, no, this is pretty cool. Amazing work from you and the rest of the engineering team here. I know you also have Turn Relay as one of your responsibilities and the work you drive. And you recently did some regional expansions, like making it more broadly available and making it available in different regions that didn't have good latency or performance and experiences. Can you tell some more there?
So we are continuously improving or investing into our infrastructure as well as in the transport layer, so that until this feature that RDP multipath goes out, we want to have customer getting the better connection reliability in all the scenarios that we have. As part of our infrastructure environment expansion, we are moving from 14 regions to 48 regions. What does that mean is basically the user, when they're connecting to their Cloud PC, they get connected to a turn relay which is closer to them. And then the maximum leg of the connection goes through the Microsoft Azure network, which means they have a faster, lower latency connectivity. Secondarily, these turn relays that is dedicated only for Windows 365 and AVD traffic, and it's optimized for that. So it is super fast, more reliable. And as part of this whole infrastructure modernization, we have come up with very reduced, simple to configure network configuration, which the the admins will be able to configure into their network setup. And in case of some, for very complicated, high security customers, which were not able to configure UDP flow, will be able to easily bypass our traffic due to this modernization in the infrastructure that we are currently doing. So this particular feature will dramatically enhance the performance for the user as well as experience across the platform. But to you, Christian, if you have any questions over here.
Now, this is great. And I think with the multi-path feature, the combination here in terms of latency disconnects really create a new kind of enhanced experience, right? Do you agree with that?
Yeah, this is like together, everything will help in connection reliability. For example, like until we roll out RDP short path, this is a feature which is like acting like a stopgap for the users who are already getting UDP so that they get better performance. Those users and the customers who are not getting UDP, because we have expanded to additional regions such as the South Africa West and South Africa North and few regions in India, so that you get better connection reliability with it. Moreover, when multipath will come in, you'll have more such different paths, network paths connecting to your Cloud PC, which will not have a single point of failure. So that if one turn relay goes off, for example, you have other turn relay which is close by, which is not impacting their connection experience, user experience. So overall, it's like we are moving forward in a way such that, and putting a lot of effort so that the keeping user experience into the mind and making it simpler and making it simple so that they get a better experience in.
That's great to hear. And one of the things is, what if I'm a government cloud customer? Is that coming as well? Is that already supported?
Yeah, so that's a very great question, Christian. So as part of this particular project, we have different phases. So for the first phase, when where I said like we are including 48 regions, the GCC environment is one of the regions that we will be adding into the list. And we have few phases, and this is like a continuous ongoing process where we'll continuously keep on adding more regions. We'll continuously add more, give support for those special unique clouds going forward, and existing, we'll keep on adding new regions, for example, in the South American countries, or as and when those network infrastructure is available by Azure to us. So yeah, it's a continuous journey. We don't stop over here. But we will start from here.
Yeah, thanks for sharing that. And one of the things we recently did too in kind of the network area is improving the experience for customers using Zscaler. Is that something you can share more on what we did there?
Yeah, so this is an awesome feature which has been worked on by my colleague called Paul Cullinch. And he collaborated with Zscaler, where he made it very easy to configure Windows 365 and AVD traffic to be bypassed in a form of simple click. It is really helpful for a lot of customers who have Zscaler as their network configuration as part of their network ecosystem.
Thanks, Rinku. And just for simplicity reasons and for the audience, we'll put the link to this blog in the screen here. Angelo, going back to you, talking about like GPU acceleration and enhanced experiences and such, we recently released HEVC, right? Can you share some more, like, what does that mean and how does that work and how does it impact the GPU experience?
Yeah, totally. So I know you did a fantastic episode with our colleagues Ron and Femi last year on GPU-enabled Cloud PCs. And so when we made GPU-enabled Cloud PCs generally available in our Windows 365 offering, having a GPU on the remote computer really unlocked the ability to execute graphics heavy, graphics intense workloads like 3D design, animation, modeling, game development, host of other use cases where the CPC can be relied upon to carry out these really intense graphics processing. Now, when our end users who are engaging in those workloads are performing those workloads on their remote machines, they also expect that what they see on their local client machine reflects the high quality graphic work that's being performed. And so to that end, we've focused a lot heavily on improving how we can leverage the GPUs, the GPU hardware on those remote machines to accelerate the encoding process for our graphics pipeline that gets delivered and rendered on the client machine. So I know you asked about HEVC. So we went into public preview last year with something that we refer to as HEVC graphics acceleration, or hardware accelerated HEVC graphics encoding. So going back to when we made those GPUs generally available, we had a hardware accelerated graphics encoding capability that used the AVC codec to compress those graphics frames and send them from the host to the client. This hardware acceleration basically taps into the power of those GPUs, and instead of relying on the CPU to encode all of the graphics and frame and action that's happening on the remote session and then sending that down to the client machine, we're using the kind of specialized graphics processing unit to encode those frames and send them to the client machine. Now, AVC was a great way to take advantage of that, but what we've introduced into public preview last fall is that hardware acceleration, but using a much more efficient codec, the HEVC or H.265 codec. Compared to AVC, HEVC allows for about 25 to 50% better data compression. So what that does is it unlocks higher fidelity graphical experiences like 4K at a 60 frames per second frame rate. It unlocks those scenarios for our GPU-enabled Cloud PC users at a wider range of scenarios where they may have lower bandwidth that might not support AVC. We've got a demo if we can show that.
Yeah, let's do it. I'd love to see it.
Now, as you can see from the demo, in the Windows app, the user is going to connect to their GPU-enabled Cloud PC, where the 3D rendering app is already running from a previous session. They're going to check and confirm a 4K by 60 FPS output before they go ahead and begin the rendering process. The user is then going to disconnect from the Cloud PC, go to work on a different PC, come back 30 minutes later, and then they're going to find a completed render performed by the GPU CPC, viewed on their 4K monitor, and they can confirm the frame rate through the connection information bar. Again, this HEVC graphics acceleration entered public preview last fall, and you can learn more about it at the learn.microsoft.com link that I believe we can share on graphics acceleration.
Thanks, Angelo, for this great demo. And let's switch persons but not shirts here, as you noted, right? Two of the same shirts here. So Jordan, back to you to wrap us up.
Thanks, Christian. So yeah, like everything we've shown today, like I wanted to reiterate that anything we do from like local, it crosses these multiple points from silicon to systems, Windows Cloud streaming. This is why we are not just shipping RDP anymore. We're trying to ship something new, which is this like local microservice end-to-end experience for folks. And so to wrap us up, we wanted to briefly touch on some features that have been shipping recently and then some that will be coming up. So in that streaming, Rinku talked with us about the turn relays and then the one-click bypass for the Zscaler. We've shipped a bunch of other features in the Windows Cloud from some of the Microsoft Teams optimizations that we've talked and had demos of previously on this channel, as well as some auth and what Aang just mentioned around HEVC. And in addition, some features that are coming up, we've already talked about the RDP multipath that Rinku was working on, as well as the continual iteration of making connectivity as fast as possible. And I also wanted to call out our Cloud NPU platform, NPU being Neural Processing Unit, which is our platform to basically enable some of these Copilot PC-like experiences in the cloud for our Windows 365 products. And so we're really excited with all the work that we have going on. Back to you, Christian.
Yeah, this is so cool. And the future is so cool from the fact of creating like experiences coming from the cloud without having any hardware boundaries, like the NPU cloud platform, for example. So you can experience from any device those AI experiences and as well other experiences that you and the team are building. So wrapping us up here, how can people stay in touch with you, Jordan, if they have any feedback or they want to talk with you about some of these things they learned today?
Yeah, if people have any questions, you can always reach out to me on LinkedIn.
Yeah, thanks, Jordan, as well to know where to buy that shirt, potentially, right? Hey, Rinku.
It'll cost you extra.
Rinku, how can people stay in touch with you?
Yeah, same as Jordan, they can reach out to me in LinkedIn. And if they have any questions, any feedback, I'm happy to learn and answer them.
Thanks, Rinku, for again being part of this show. And last but not least, ending out with you, Angelo. How can people stay in touch with you?
Yeah, just like my colleagues, LinkedIn's a great platform to connect with me on. Angelo Gakatsiosin, the spelling, pronounced a little bit differently.
Well, thanks all for being here and sharing these great insights and demos to this audience. Definitely want to get you back because this is like an ongoing evolution of experiences coming to life. And thank you for watching, and please ensure to stay up to date about all the latest Windows 365 and Azure Virtual Desktop news via ak.ms/Windows in the Cloud. So thanks for watching and hope to see you back next time.